Now let's just move on further towards the concept of pair of angles. So first of all, we already are now aware about what are the vertically opposite angles, what are the adjacent angles, what are some of the properties that are related with the adjacent angles, what are complementary angles, what are supplementary angles. So we all are aware about now such kind of the angles, what are straight angles as well. So now here, let us suppose if I'm just drawing a particular kind of a figure in which a ray is actually standing on a particular line. So let us suppose if I'm just taking a figure of such a type. As you can see over here, the ray is actually standing on this ray, that is OC, is actually standing on this particular straight line, that is AB, and here three angles are formed. Here three angles are formed. And what are those? Let us suppose if I'm just writing it over here, the first angle is angle AOC, the another angle is angle BOC, and the angle AOB. So here we have three angles. What are those? This is the angle 1, this is the angle 2, and this whole angle is nothing but the angle 3. So we have AOC, BOC, and AOB. So we can generate a particular relationship in between these three angles. How we can generate it? Let us suppose if I'm just recalling the adjacent angles. I hope you remember the adjacent angles, that the adjacent angles are nothing but the two angles that are formed in between the two angles in which we have the same vertex. We have a common arm. We have the same vertex over here. We have a common arm over here. This is nothing but a common arm. And the two non-common arms are actually on the opposite side or not on the same side of the common arm. So such two angles are nothing but called as the adjacent angle. So these two angles, that is angle AOC and angle BOC, are actually nothing but called as the adjacent angles. So it implies that angle AOC and angle BOC are adjacent angles by definition of adjacent angles. By definition of adjacent angles, they are nothing but the adjacent angles. And we know about a certain property of an adjacent angles, that the sum of the two adjacent angles, is nothing but is equal to the angle which is formed by their non-common arms. The angle which is formed by their non-common arms. So what are the non-common arms over here? This is the very first non-common arm. This is the very first non-common arm, and this is nothing but the second non-common arm. So this is actually nothing but is equal to the angle AOB. So why I'm writing this? Because we already know that the sum of the two adjacent angles, is equal to the angle formed by their non-common arms. So that's why I'm writing angle AOC plus angle BOC is equal to AOB. Now let us suppose if I'm just taking this as nothing but the equation number 1. Now again we know about a particular concept, that this AOB is actually forming an angle which is nothing but called as a straight angle. And the measure of a straight angle is nothing but 180 degree. We already know about this concept, that the straight angle, that is AOB, is actually forming a straight angle which is nothing but of the measure of 180 degree. So it implies that the angle AOB is nothing but is equal to 180 degree, because it is nothing but a straight angle. It is a straight angle. So let us suppose if I am calling it as second. So using first and second, what I can say? I can say AOC plus BOC is nothing but is equal to 180 degree. AOC angle plus BOC angle is nothing but is equal to 180 degree, which leads us to our special axiom. And the axiom says that if a ray is actually standing on a line, then the sum of the two two adjacent angles so formed is nothing but is equal to 180 degree. 180 degree. So this is nothing but the proof of this axiom. You can see that angle AOC plus angle BOC, angle AOC plus angle BOC, and this is nothing but a ray which is standing on a particular line, and this leads us to this information that AOC plus BOC is nothing but is equal to 180 degree. So this is a very special axiom which leads us towards some other statements as well. So let's just see this axiom again, that recall, if a ray stands on a line, whenever remember a ray stands on a line in such a manner, then the sum of the two adjacent angles so formed is nothing but 180 degree. Now let's just see the axiom 1 again. So according to the axiom 1, if a ray stands on a line, then the sum of the two adjacent angles so formed is nothing but 180 degree. We have proved this axiom as well. So keeping in view this axiom, we can say that when the sum of the two adjacent angle is 180 degree, then they are called as a linear pair of angles. So remember this concept, that whenever we have the sum of the two adjacent angle is as 180 degree, then those angles are nothing but called as the linear pair of angles. They are called linear pair of angles. So let us suppose, if keeping in the axiom 1 in my mind, I'm just rewriting the statement, that is the axiom 1 again. So if I'm just rewriting the statement, I'm writing it in such a manner that if the sum of the two adjacent angle is 180 degree, then a ray stands on a line. So you can see all by yourself that the very first statement and this statement is actually looking at the reverse of each other. They are actually the reverse of each other, because here we are starting with if a ray stand on a line, and here we are ending with then a ray stand on a line. So from this concept, we definitely know they are converse of each other. These two statements are actually the converse of each other, but we do not know about the authentication of this particular statement, that whether it is true or false. So let's just see whether this statement is true or not, that if the sum of the two adjacent angle is 180 degree, then a ray stands on a line. So let us suppose if I'm just drawing some of the adjacent angles with a different measure. So let us suppose if I'm just taking 3 cases over here, and you can see these are all the adjacent angles. So as you can see, for the second case only, if I'll just take a ruler along this AOB, then this is definitely nothing but forming a straight angle, and furthermore the sum of the two angles is nothing but 180 degrees. So this particular example is actually telling us that if the sum of the two adjacent angle is actually nothing but 180 degree, then the ray actually stands on a line, and this is nothing but a straight line. You can see all by yourself that their non-common arms are actually in forming a straight line altogether. So hence the axiom number 2 can be stated as, if the sum of the two adjacent angle is 180 degree, then the non-common arms of the angles form a line. So we can give the statement that we already have discussed in the previous statement as a converse of the axiom number 1. We can also rewrite it into the formation of an axiom, and that axiom is nothing but the axiom number 2, which says that if the sum of the two adjacent angle is 180 degree, then the non-common arms of the angles, they form a line. And you can see this all by yourself. Because of this second figure, I can say this particular fact. Now let's just take the two axioms together. So if I'm just writing the two axioms together, let us suppose if I'm just taking the axiom number 1 and if I'm just taking the axiom number 2, so you can see the axiom 1 and the axiom 2 all together are actually called as nothing but the linear pair axiom. So whenever we are just talking about the linear pair axiom, so these two axioms all together, they are nothing but called as the linear pair axiom. So this is all about the pair of the angles.